Typically, household voltage in North America is nominal 120 volts, specifically in the range of 110 to 125 volts for standard circuits. However, it's crucial to understand that voltage can vary depending on several factors. One key factor is the distance from the transformer. The further you are from the transformer supplying power to the house, the more the voltage can drop due to the resistance of the wiring. Another factor is the load on the circuit. When more devices are drawing power from a circuit, the voltage tends to decrease because the wiring has a certain amount of resistance. Finally, the condition of the electrical wiring plays a significant role. Old or damaged wiring can have higher resistance, leading to voltage drops. Voltage drop occurs when current flows through a conductor such as wiring. The amount of voltage drop depends on the load, the length of the conductor, and the conductor gauge. A higher load, a longer conductor, or a smaller gauge conductor will result in a greater voltage drop. During times of high energy use, voltage drop can increase significantly as more appliances and devices draw power simultaneously. Voltage spikes are sudden brief increases in voltage. These can be caused by several factors. One common cause is the switching of inductive loads, such as motors and compressors. When these devices turn on or off, they can generate voltage spikes. Another cause is lightning strikes, which can induce large voltage surges in the electrical system. Power surges from the utility company can also cause voltage spikes. Voltage spikes can range from a few volts to several hundred volts above the normal voltage. They typically last for a very short time, from a few milliseconds to a few seconds. To monitor voltage over time, there are inexpensive voltage recorders available. These devices can track voltage and record the highest, lowest, and average voltages. They typically have a display or memory that stores the recorded data for later analysis. There are several examples of voltage recorders on the market. These examples include the Fluke 345 Power Quality Analyzer, the Extec 400 80520 Mini Power Analyzer, and the Ideal Industry SureTest Voltage Recorder. When selecting a voltage recorder, there are several factors to consider. Firstly, accuracy is crucial. Look for a recorder with a high degree of accuracy to ensure reliable measurements. Secondly, consider the recording duration. Choose a recorder that can record voltage for the required period, whether it's hours, days, or weeks. Thirdly, ease of use is important. Opt for a recorder with a user-friendly interface and intuitive controls. Fourthly, data storage capacity is essential. Ensure the recorder has sufficient memory to store the recorded data. Fifthly, connectivity options should be considered. Look for a recorder that offers connectivity options such as USB or Bluetooth for easy data transfer to a computer. When dealing with electrical systems and voltage, it's always important to prioritize safety. Firstly, always turn off the power at the circuit breaker before working on any electrical wiring or equipment. Secondly, use appropriate personal protective equipment such as insulated gloves and safety glasses. Thirdly, follow all applicable electrical codes and regulations. Fourthly, if you are not comfortable working with electricity, consult a qualified electrician. Understanding voltage variations, voltage drops, and voltage spikes is crucial for maintaining the health and efficiency of electrical systems. By monitoring voltage and addressing any issues promptly, you can prevent damage to equipment, reduce energy waste, and ensure a safe electrical environment. Now let's delve a bit deeper into the specifics of voltage ranges and their impact on various electrical components. The nominal voltage of 120 volts is the ideal target, but fluctuations are inevitable. Acceptable ranges generally fall within plus or minus 5% of the nominal value. This means that a voltage range of 114 volts to 126 volts is typically considered acceptable. However, exceeding these limits can lead to problems. Firstly, undervoltage, or voltage below the acceptable range, can cause equipment to operate inefficiently or even fail prematurely. Motors may run hotter, lights may dim, and electronic devices may malfunction. Secondly, overvoltage, or voltage above the acceptable range can also damage equipment. It can cause overheating, insulation breakdown, and component failure. Sensitive electronic devices are particularly vulnerable to overvoltage. The distance from the transformer plays a critical role in voltage regulation. Transformers are designed to maintain a stable voltage output, but the further away you are, the more the voltage can drop due to the resistance of the wiring. This is why it's important to use appropriate gauge wiring for long runs to minimize voltage drop. The load on the circuit also affects voltage. As more devices draw power from a circuit, the voltage tends to decrease. This is because the wiring has a certain amount of resistance, and the voltage drop is proportional to the current flowing through the wiring. To mitigate voltage drop, it's important to distribute the load evenly across multiple circuits and avoid overloading any single circuit. The condition of the electrical wiring is another important factor. Old or damaged wiring can have higher resistance, leading to voltage drops. Corrosion, loose connections, and insulation breakdown can all increase resistance. Regular inspection and maintenance of electrical wiring are essential to ensure proper voltage levels. Voltage spikes, also known as surges or transients, are sudden, brief increases in voltage that can damage sensitive electronic equipment. They can be caused by a variety of factors, including lightning strikes, power surges from the utility company, and the switching of inductive loads. Lightning strikes can induce extremely high voltage surges in the electrical system. These surges can travel through the wiring and damage any connected equipment. Surge protectors can help to mitigate the effects of lightning strikes by diverting the surge to ground. Power surges from the utility company can also cause voltage spikes. These surges can be caused by grid switching, equipment failures, or other disturbances in the power grid. Surge protectors can also help to protect against power surges from the utility company. The switching of inductive loads, such as motors, compressors, and transformers, can generate voltage spikes. When these devices turn on or off, they can create a sudden change in the current flow, which can induce a voltage spike. Surge protectors with inductive load protection can help to suppress these voltage spikes. Inexpensive voltage recorders are valuable tools for monitoring voltage levels and identifying potential problems. These devices can record voltage over time and provide data on the highest, lowest, and average voltages. This data can be used to diagnose voltage drops, identify voltage spikes, and assess the overall health of the electrical system. There are several types of voltage recorders available, ranging from simple plug-in devices to more sophisticated data loggers. Plug-in voltage recorders are typically small and inexpensive devices that plug directly into an electrical outlet. They can record voltage over time and display the data on a small screen or store it in memory for later retrieval. Data logging voltage recorders are more advanced devices that can record voltage, current, and other electrical parameters. They typically have a larger memory capacity and more sophisticated data analysis capabilities. When selecting a voltage recorder, it's important to consider the following factors: accuracy, recording duration, ease of use, data storage capacity, and connectivity options. Accuracy is critical for obtaining reliable data. Look for a recorder with a high degree of accuracy to ensure that the measurements are accurate. Recording duration is the length of time that the recorder can record data. Choose a recorder that can record data for the required period, whether it's hours, days, or weeks. Ease of use is important for being able to set up and operate the recorder easily. Look for a recorder with a user-friendly interface and intuitive controls. Data storage capacity is the amount of data that the recorder can store. Ensure that the recorder has sufficient memory to store all of the data that you need to record. Connectivity options allow you to download the data to a computer for analysis. Look for a recorder that offers connectivity options such as USB or Bluetooth. Maintaining proper voltage levels is essential for the reliable and efficient operation of electrical equipment. By understanding the factors that affect voltage and using voltage recorders to monitor voltage levels, you can prevent damage to equipment, reduce energy waste, and ensure a safe electrical environment. Now let's move on to more advanced topics related to voltage and electrical systems. We'll discuss grounding, bonding, and surge protection in more detail. Grounding is the intentional connection of an electrical system to the earth. The purpose of grounding is to provide a low impedance path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock hazards. Grounding is typically achieved by connecting the neutral conductor of the electrical system to a grounding electrode, such as a ground rod or a metal water pipe. Bonding is the connection of all metallic parts of an electrical system to create a continuous electrical path. The purpose of bonding is to ensure that all metallic parts are at the same electrical potential, which helps to prevent electrical shock hazards. Bonding is typically achieved by connecting all metallic parts, such as metal conduit, metal enclosures, and metal equipment, to a grounding conductor. Surge protection is the use of devices to protect electrical equipment from voltage spikes. Surge protectors work by diverting the surge current to ground, which prevents it from reaching the protected equipment. Surge protectors are available in a variety of types, including whole-house surge protectors, point-of-view surge protectors, and surge protective devices. Whole-house surge protectors are installed at the main electrical panel and protect all of the equipment in the house from voltage spikes. Point-of-view surge protectors are plugged into electrical outlets and protect individual pieces of equipment from voltage spikes. Surge protective devices are installed inside of electrical equipment and protect the equipment from voltage spikes. Selecting the right surge protection for your needs depends on several factors, including the level of protection required, the type of equipment being protected, and the budget. It's important to choose surge protectors that are rated for the voltage and current levels of the electrical system. Regular inspection and maintenance of surge protectors are essential to ensure that they are functioning properly. Surge protectors should be replaced periodically, as they can degrade over time due to repeated exposure to voltage spikes. In addition to grounding, bonding, and surge protection, there are other measures that can be taken to improve the safety and reliability of electrical systems. These measures include using appropriate wiring methods, installing ground fault circuit interrupters, and following all applicable electrical codes and regulations. Using appropriate wiring methods is essential for preventing electrical hazards. Wiring should be installed in accordance with the National Electrical Code and other applicable codes and regulations. Ground fault circuit interrupters are devices that detect ground faults and interrupt the circuit, which helps to prevent electrical shock hazards. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. Following all applicable electrical codes and regulations is essential for ensuring the safety and reliability of electrical systems. The electrical codes and regulations are designed to protect people and property from electrical hazards. By following these codes and regulations, you can help to ensure that your electrical system is safe and reliable. Understanding voltage variations, voltage drops, voltage spikes, grounding, bonding, and surge protection is crucial for maintaining the health and efficiency of electrical systems. By monitoring voltage, protecting against surges, and following all applicable codes and regulations, you can prevent damage to equipment, reduce energy waste, and ensure a safe electrical environment.